All right, 8.2, proving triangles similar by AA. So if you remember back to congruent triangles, we talked about that there was no AAA congruency, okay, because that was not enough. We needed at least one side somewhere in one of those rules to prove congruency. But if you have two angles, okay, we're going to learn that you can still prove them similar. So a little bit of review first. Find the value of x. Well, we know this angle right here is 34. We know this angle is 90. We don't know this angle. But we have an x right here, and these are vertical angles, which means this is x also. Okay? So therefore, we can say 90 plus 34 plus x equals 180. And remember, there is a shortcut. We'll talk about that afterwards. Okay? So 90 plus 34 is 124 plus x equals 180. And then all we're going to do is subtract 124 from 180. And that gives us 56. Remember, though, we talked about a shortcut. If we know this is 90 right here, then what's left in the triangle? 90. So we could have just done x plus 34 equals 90. And then when we subtract 34, guess what we get? 56. It's a little bit of a time saver. It's not huge. Okay. Apparently my music was playing in the background, but I didn't know because it's muted. So here we go. All right, so what do we have here? Well, we know that that's equal to itself by the reflexive property, and we know that we have side, side, side. So we know these two triangles are congruent. Therefore, if we know this is 100 degrees, we know this is 100 degrees also. Or if we know this is x, we know this is x. Either way, same thing. We're going to be doing 100 plus 61 plus x equaling to 180. Okay? So that obviously gives us 161 plus x equals 180. All right? And then if you could do it mentally in your head, if you did 180 minus 160, right, you would get 20. Okay? And then you would just have to make the adjustment for the 1 and get x equals 19 because you're taking one more extra away. So 180 minus 160 would be 20. Take away one more and you get 19. So here is that theorem. If we have two angles in two triangles that are congruent, we know they're similar. They could be congruent. All right? If we knew, ASA or AAS, something like that. But at least we know they are similar. And consequently, we talked about there was no AAA congruency. Well, if two angles are the same, we know the third one must be the same, but we don't have to bother calling it AAA because we have that already learned rule that if two angles are the same, the third one must match. So instead of calling it the AAA rule, we just call it AA. All right, determine if they are similar. These two triangles are similar. Well, we have a 90-degree angle here and here. The problem is we have a 26 here and a 64 here. Well, let's find out what this missing angle is here. Or we can find out this one. It won't matter. So, again, I'm going to take the shortcut here. If I've used up 90, that means there's 90 left. So 90 minus 64 equals 26. Or over here, I could have done 90 minus 26 and gotten 64. What that tells me is I have at least two angles that match. I have all three angles now, but whichever way I went, I could have proven them similar. Now, we have to get the statement right, so we have to go in the same order. So let's say I say CDE, CDE. That means I am starting at the 26, going to the 90. So over here, if I start at the 26 and go to the 90, that would be K, I can't read because I covered it up, KGH. All right, and we've proven that two angles the same. We actually proved all three because I did it both ways, but that's all you need. All right, the first one here is one of those ones where I like to do this and then do this because I think it's a little bit easier. Now, A is congruent to itself by the reflexive property. We also know that 52 is here and 52 is here. Okay. So it says, show the two triangles are similar. Well, we have two congruent angles, 52 and whatever A is. It doesn't matter. We just know they're the same. That's all we need. All right. Whenever we see our bow tie, the first thing we do is always mark angles congruent. So we know we have at least those two angles are the same. We just need to find one more. And since these are parallel lines, we've talked about this before, whenever we have parallel lines, okay, we're going to have alternate interior angles. Okay, so we know that angle SVR is congruent to angle UVT, okay, because of alternate interior angles. And we know, oh wait, sorry, I got those mixed up. SVR is vertical angle, and UVT is, so I got ahead of myself. Vertical. Okay, and then SRV, sorry about that, is congruent to angle UTV by AIA. So we have two angles, two congruent angles again. Okay. A flagpole casts a shadow that is 50 feet long. So this right here is 50. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. Okay. How tall is the flagpole to the nearest foot? Now, there are two ways to do this problem. Okay. I'll tell you both of them and tell you which one's easier. We need to have the same unit. So both inches are both feet. She's 5'4". Okay. So we can convert her to feet as a fraction and 40 inches to a fraction answer. All right. And then deal with the 50. Or we just turn 50 into inches. Now, the final answer's got to be into foot. But personally, I think it's easier to change one thing here and at the end fix it. But it's up to you. But I'm going to change this 50 feet. Okay. So there's 12 inches in a foot. All right. So 50 times 12 is 600. So 600 inches. All right. She's 5'4". So 5 times 12 is 60. So she's 64 inches tall. So now I'm going to set up my, let's see, her and the building. I'm going to do height and shadow. Doesn't matter. You could mix this up like I've talked about before. But this makes life a lot easier. So her height is 64 inches tall. The building height, we don't know. Her shadow is 40 inches tall, and the building shadow is 600. So we're going to get 40x equals 64 times 600, which is 38,400. And now we're going to divide by 40. That's 960 inches. And then to convert to feet, all we're going to do is divide by 12. So the flagpole is 80 feet tall. All right. So it's up to you, but I promise you that's a lot easier than doing it the other way, because these would both be fractions and you'd have all this nasty work to do with it. This is easier. All right, exit ticket. One triangle has angles of 18 and 96. So I'll start this for you. You finish it. So 96 is going to be a little bit bigger than a right angle, and one of them is 18. A second triangle has also 96, but that's way bigger, but we'll go with it. But one angle is 56. Are they similar? So hint, hint, either find this or find this and see if they match. That's it.